Yeah, but it is quite useful just to learn about these libraries. These are libraries that, as Andrew said, part of your programming toolbox. Like we have pandas now NumPy as well. But again, if you don't plan on using linear algebra or doing numerical simulations, then you don't necessarily have to know how this library works. If you're just planning on reading in CSV files and doing manipulation of data, pandas is more than capable and a lot easier to use than NumPy. So NumPy has very specific use cases, as Andrew showcased yesterday. So don't get too bogged down about I have to learn NumPy now and everything else. This is a brief taste of what you'll see next week, where you'll see other libraries as well, and things will get more complex. So the idea is not to be bogged down by the complexity, but more look at the use cases. And even if it's not in your domain area, the code is really just the same lines of code are quite similar. So if it's out of your domain area, for example, just look at the code and how they're programming the examples, because that you can benefit from in itself. Just coding and practicing the same code they're doing, try to get the same outputs. You might not, need to use these kinds of libraries or operations, but at least you'll get the coding practice. Okay, so again, if you found yesterday's presentation on NumPy a bit too complex, again, it's a domain area that might be out of your scope, so don't worry about it. You don't have to know NumPy. Just know what you think you'll need to know. And I think, again, pandas is probably the most generic library that everybody should know about. It's quite easy to use, as we've kind of gone through the past 3 days. But yeah, the notes are there. So you can go through it, and if you have any questions, more than welcome to put it in the chat or ask Andrew directly. So next week you will see a few of the lecturers using NumPy as well. It is a foundational library for various other subjects next week, so you will see it. So that's why we decided to add this, just a bit of introduction on how it works and its various use cases. All right. There was a few other things that Andrew mentioned, which I'll review only tomorrow, because tomorrow is going to be more of a review and kind of a exploring Python and the programming language itself and different ways to use it, and how it's used in the world today. And we also look at Jupyter Notebook, because it's also important. A way of using Python is to know how Jupyter Notebooks work, or Jupyter Labs if more advanced one. But we'll look at Jupyter Notebook because some of the lectures next week again will be using Jupyter Notebook, not Spider, to present the content. And Jupyter Notebooks are used a lot in tutorials online for Python. So it's important just to review it, see how it works, and if there are any questions about it. But today we're taking a bit of a break from Python completely, and we're looking at a section which we are renaming to Bash and file management. And this all ties in, there's various, terminologies we should discuss before we kind of understand what is Bash and primarily file management, because again, we can't go into too much depth, but this is the main aspect that you really will focus on when you're as a researcher and you need to use a Bash terminal is navigating your directories and your files. There are many other things you obviously can do with Bash terminal and everything else, but again, we don't have enough time for that. The CHBC Winter School goes into a lot more depth into Bash terminals and logging into the cluster and running simulations. So we have a dedicated course for that. This is just a real taster to get understanding what is Linux. So as the question or as the heading states there, what is Linux? So I actually decided to take a few pictures or images of that might give you some context first before we go through this content. Because if you're used to Windows, you might not have heard of Linux at all. So I found this few images, which I found quite funny. So as you see, Woody astronauts use Linux because you can't open Windows in space, which is very accurate. And Linux is everywhere, and it literally is everywhere in all the services that you might use on a day-to-day basis, all the cloud services that you use, all the servers and everything else. Foundationally, it is built on Linux. And here's just a bit of a breakdown of the various use cases where Linux is. So again, Linux is just a different operating system. The majority of you, according to the registration statistics, I think about like 70% use Windows, right? So you might be familiar with Linux. If not, just know that it is. So just know it is a different type of operating system to Windows, and obviously there's also Mac has Mac OS as well. But obviously we're speaking about Linux here and the various use cases for it. So one statistic you can maybe focus on here is of the top 1 million servers, web servers use Linux. 80% of web servers are Unix-based, and there's various other stats. So almost 498 of the top 500 supercomputers run on Linux. So again, just gives you a bit of idea of where Linux is used. It's pretty much used everywhere. We obviously just are quite familiar with Windows because it's very visual. Linux is all terminal-based, coding-based, text-based, right? So this is, the majority of where Linux is used. Obviously, there is a visual GUI interface, which is similar to Windows, but that's not really where the power is with Linux. It's a terminal is where the power is that's used. And many times you'll see when you're watching, movies or whatnot, there's usually like some kind of a hacking scene or somebody's programming and they're hacking into somewhere and trying to gather information. So I found this video, this hacking meme of, it's really an exaggeration of what they really do in the movies. It's not really like that, but I thought this video was quite funny, just to give you some context. So I'm just drag it across properly. So what you usually see is a dark room somewhere, and somebody typing really fast on many computers, and there's a green background, right? Many keyboards everywhere. Guy typing with his foot. So really, it's really ridiculous. Like the examples they have in movies in most cases. I'm not sure whether smoking comes into it, but you kind of get the idea, right? So in movies, they show people that have many terminals and they're typing a lot. They're almost typing like it's like typing on a keyboard, like a piano, actually typing so fast and all this stuff. But usually it's like single commands. They're waiting for stuff to load. They never show when stuff loads, really. Just typing a lot. It sounds like they're playing a piano. But in any case, that's just the movies for you. So we can briefly go through some of the descriptions so we all on the same page. So what is Linux? It's an open source operating system, so it's completely for free. Obviously compared to Windows, which you have to pay for. And it's widely used for servers, embedded systems. So when you think of your or your cloud servers like OneDrive or Google Drive, how those are operated and run, they're all Linux based. Again, so it's really a very widely used operating system. So one of the distributions, which is developed by a South African, is called Ubuntu. It's probably one of the most popular Linux operating systems to use that most people are familiar with. And I guess you get different other distributions that are similar to it, but it almost has like a Windows feel. You get another one called Mint as well that also looks like Windows. It has a visual application to it, so you can, if you're familiar with Windows, you can easily transition to it. But the main power behind any Linux operating system is terminal, where you're typing text and you're doing your operations on a terminal basis. So what is it? What is a terminal? So we've kind of been exposed to a terminal to some degree already with Spider, where we had in Spider we had a console where we could input things and get outputs. So that is a type of terminal as well, or what is quite well known to be a CLI or command line interface. You input text and you get outputs, right? So that's basically what a terminal is. And the various other terminals that you'll see that you can access even on your own Windows machine. You have, if you open up your Windows machine, you can, if you type here, if you just type in DOS, you'll get another type of terminal here. If you click on search bar and you click on DOS, you'll get another terminal that pops up. This is native to or specific to Windows. If you want direct access to Windows, this is where you'll be working and putting in commands. There's another one called PowerShell as well. If you go PowerShell, Windows PowerShell, it's a bit closer to kind of a Linux terminal or Bash terminal, as we'll get to, because it can accept Bash commands, which we'll get to. But again, you've almost direct communication and control with Windows. There is a kind of a simulation of a Linux environment or Linux terminal called Windows Subsystem for Linux. So you can run a little Linux operating system inside Windows itself, and it does work fairly well. So another thing I forgot to mention, as my colleague Mteto mentioned, is that Linux is also known for stability and security, fewer vulnerabilities and low risk of viruses and malware compared to Windows, right? That's why all our servers, Google Drive, OneDrive, all these servers are, all the websites that you're running, the foundational operating system is Linux because it's secure, safe, and you have full control over it, right? So you can say it runs the world, the digital world to some degree. All right, and there's a little snapshot from the movie The Matrix. Do you remember what the actor's name was in this? What his name was in The Matrix? Sorry? No. The guy behind the terminal that got everybody inside and outside the Matrix. Was it Tank or was it Link? I can't remember. Was it Tank or Link? One of them. No. Tank was the big guy that was electrocuted. It was Link, because he linked everybody to the Matrix. But again, he's like typing all the way, and that on a terminal, right? Obviously, the Matrix must use terminal, not the Windows-based operating system. Okay, so terminal, we've again been exposed to it in sort of Spider already with console, where you input and output certain commands, and we've seen it to some degree with Spider. Now, what is Bash? So Bash stands for Born Again Shell. It is a command processor. Again, provides a CLI, command line interface with the operating system. It's a default shell for many Linux distributions. So Ubuntu and Mint and most Linux distributions use Bash. And it allows you to automate tasks, write scripts, and execute complex commands. So we'll be learning Bash today. So there are it's just a type of terminal, right, that we're going to use. For example, on a Mac operating system, they don't necessarily use Bash. They use, I think, ZSH or Z shell. But again, the commands or the syntax or how you type these commands are pretty much the same. There's very few things that differ. Okay, so now, very importantly, why learn this stuff? We thought we were reading in Excel files and making nice and pretty with plots, and now I'm back to the command line, these really dull text. Now, why is it actually useful, to learn this skill again? So I wanted to spend a bit of time on this. So obviously, it is a skill. You can either take it or leave it. It's really up to you, but it's useful to know how it works. So one of the things we're obviously trying to teach you with Python is to automate really boring and mundane tasks that you typically would do in Excel or with your folders. You can easily do in Python. So hopefully you got some of that from Python and using pandas specifically. But again, that is one part of it where we really have the data. But many cases when you want to, your data might be too large, either too large or too complex. In that case, your data might be on another server somewhere and you have to extract it. So in that case, you would connect to it using use some kind of a terminal, like a bash terminal, most likely. So there's a few reasons why you should learn bash. One of them again is automation. So automation in the sense of writing repetitive or writing scripts or a recipe of instructions to do data pre-processing, analysis, and simulations for remote servers, which I think many people or some of you might already be using already. Researchers often work with remote servers for high performance computing, or or if you have a complex problem is one thing is HPC, or high throughput if you have large data, HTC, or even cloud computing if you are working with any servers. So bash commands are crucial for managing, well, first connecting to the servers, managing files, executing tasks on the servers. Maybe every day you're doing a simulation and you need to get that data each day. You can write a script to extract it information for you. Because most of the servers only offer you a terminal to work with. They don't offer you like a nice Windows GUI environment. Another useful thing to learn about bash is version control. So for those that obviously have no experience with programming, you've been introduced to GitHub to some degree, and storing data on a cloud, and maybe making edits to that, and looking at the history of those changes. So that primarily is what we call the version control, which is for GitHub, it's based on Git. You get different types of version control means. Git is one of them. But using a terminal allows you to also control, the version control of your files in terms of updating your files and committing it to GitHub and other repositories. Another reason, possible reason is data exploration. Just like we've done in pandas, where we can explore the data and look at it to some degree. You don't really have the luxury sometimes to do that. You first want to maybe look at the data. You've done a simulation and you run it and just want to have a quick look at the data, right? Just to explore and manipulate it, and to see the data that you've kind of extracted already, or the simulations that you've done. So again, so bash commands or learning about a bash terminal is integral for researchers to navigate, organize, manipulate files, and move around directories as well, for local servers and remote ones. So obviously we always want to try and make things efficient, make things more streamlined, to kind of make sure we focus on the research or the work we want to do, rather than doing it like mundane tasks that we can ask a computer program to do for us. So again, this might not apply to you. Maybe you're not working with servers yet, but and you're not doing HPC or HTC or cloud computing just yet. But it's a useful skill just to learn. if you're just working with Excel spreadsheets and you just need to know about Python pandas and what you did in the past few days, then that's fine. This is just an extra skill we're teaching you, which is quite beneficial. So what will we do? Again, we're taking a very easy approach to how we're teaching Bash or Bash terminals and these command line interfaces. We're going to just look at the files we have created and used for the past few days in Python. And we're going to start again from a Windows Explorer and how do we do the same stuff in Windows. If you want to rename and create files and move them around and move around your directory, how do you do the same things in a Bash terminal. There was another interface we actually showed, which I showed you briefly yesterday, which was when we need to install that one library, which was Anaconda. But I'll show you that again tomorrow. Okay, so Git Bash. So one of the at the beginning of this school, I asked everybody to install Git Bash. There was instructions to install it, and hopefully you were able to install it. There are other ways that you can obviously interact with the terminal. Git Bash is just one way you can do it on Windows. If you're running a Linux, you have already built-in terminal already. If you have Mac OS, you have a built-in terminal. I explain it already in the general section where we discuss that. So this is only for Windows users. There are other options you can use as well, as I said in the setup notes. This is just one of them, which I find quite useful as well. So one of the I guess important comments here is in Windows, if you go to any directory or file or folder, we can easily edit, copy, rename, and delete files, right? With the click of a mouse, we move stuff around, and we can, easily do that kind of things. But terminals, they do not have a mouse. You cannot move things around. You can only type, right? So what does it leave you with? It leaves you with typing the instructions. So it's almost a similar way how if you're used to Excel, all those things you've been doing to create your spreadsheets and make them look pretty and whatnot, there's no record of what you've actually done. It's in your mind at that current point, but 6 months later, if you want to reproduce that, you really can't. There's no record of really what you've done, all the mouse clicks you've done, and how you've edited the plots and everything else. So in the same way as like with Python, where we have a set of instructions that if you do it today, if we do it in 6 months, it's the same set of instructions, and those instructions repeat themselves. So you're kind of explaining the process that you have to do to read in a file, clean it up, plot it. So everything is recorded in itself. So we're doing the same thing with terminals as well. If you want to create files, rename them, move them from one place to another, it's a set of instructions that we are learning. Because again, with terminals, there's no mouse, right? You have to type everything. All the instructions are going to be typed. So if you don't like typing, well, I can't really help you there. So a typical use case is if you have data on a server, if you have maybe hundreds of files, or maybe if you want to, if you have 100 files, for example, on even on Windows, and you want to rename them for some reason, or you want to filter them, or you want to edit them in some way. Most cases you have to manually do that, or you can. There's probably other programs that could help you do that too. But working with a terminal, you have full control over all your files or how you can modify and edit it. So it just gives you more control than what you typically have in the Windows environment to rename, move around, copy, search things, update files, and much more. So this is my Spider folder that I created yesterday. Yours will probably look different. But let's first have a look at that, okay? So let me open my this one over here. This is my folder. I just copied and pasted it. So this is what you should see. Okay. If you installed Git Bash with the instructions that that you followed, that you're supposed to follow, if you click in an empty space anywhere here and you do a right click, you should see one of the options is to Git Bash here. So this will open up a terminal directly in this folder, right? And this is where we're going to start with for today and the lessons. Okay, so this is what we're going to start with. So again, your folder might look different. You can use any folder that you really worked with, but I'm using this as just an example to work off from. So I'm going to click Git Bash here, and I'm going to get a terminal that's going to pop up over here. So let me just zoom in my zoom this in so I can see a bit better. Okay, so I'll explain what this is now. So this will happen if you right click on your folder, you should see a terminal pop up. Okay. Another option of getting access to Git Bash is just go to your Windows apps, go over here on the bottom left or your window button, click on Windows apps, and you should, if you just type in bash, Git Bash, you'll have another, you can access it there too. Okay, but I prefer you to start with the folder that you're working with, and then we'll expand from there. But you can access it here too. All right, so I'm going to move my screen over here so we can clearly see what we're working with. Just minimize that. Okay. Okay, so do you have a terminal open? So please reply in the chat with thumbs up if your terminal is open, because we're going to be coding together. Or it's not really called coding really, but this is working a terminal. So just make sure terminal is open. It seems people still are not replying to the thumbs up to my. Yeah, so just reply to my posts, not another thumbs up. Wonder if there's a way in Slack to prevent a thumbs up, to post a thumbs up. Please explain with Mac. Thank you, Blessing. So normally we'll explain to you how to open up a terminal because you don't need to use Git Bash. You don't use Git Bash or if you're using a Mac or Linux, but normally she's an expert in all things Mac, so she can explain that. Okay, so you should have this open. And what does this mean? So yours will not look like mine because this is called your terminal prompt. You'll see this anytime that you open it up. It's called a terminal prompt. If you're running a Linux or Mac, your terminal prompt might look different. This is standard text that you'll see each time. This just tells me this is the username. So this is my username over here. And this is my machine name. And this is just the how the terminal is running. Don't worry about what that means. But most importantly is what you see over here. This tells me the current folder directory. The current folder directory I'm in. Okay. And where you'll be typing is over here. So you can see the blinking cursor over here. This is where you're typing your commands. Okay. So just to see how the prompt works, if you do a whole bunch of enter, you'll see any time you put any command, your prompt will always appear just to show you who's the user, what machine you're on, and the current location. So my current location is the Spider project. Yeah, again, so on Mac, don't use Git Bash. You have to use your own terminal, and it's a different process. on Mac. This is only for Windows, what I'm doing. For Mac, we have Mac experts here that will definitely explain what's going on.
So with Mac, you have to go to Launchpad where you see all your applications, and then you can search for, just type terminal where you can search, then it should pop up.
Yeah, so rather type it or send us screenshots if you want. But do it in frequently asked questions, because there'll be people that want to know. Okay, somebody asked, please repeat the steps that led to that. Okay, fine. So I go to any folder. I'm working with you should have your Python folders. I click on an empty space. So you can click anywhere really, it doesn't make a difference. If you click on your Windows here, you'll get a Git Bash. So this is, you'll see it anywhere to access Git Bash. Here I'm clicking my files, I right click, and I just click on Git Bash here. And then my bash terminal will pop up. Give it a moment. You zoom in, and there's the prompt that pops up. Tells me the user. Again, this will be different on your machine. The user, the machine name, the type of terminal I'm running, and then the folder. Let me minimize that. Okay. So everybody should be with me with that. So, okay. All right, so what is the first thing that we learned in Python to do? What's the first thing we learned in Python on Monday? What's the first thing we learned to do? The first command, first function. Print, right? We did print first. Okay, so just like any other programming language, all other programming languages have some kind of a print function to display text. So in a similar way, a bash terminal also has it. Okay, so it's not print, but it's echo. Okay, so I type echo space because it's text, it's a string, follows the same convention as all other programming languages. You need double quotes when you want to, you know, input text or words or anything. So I'm going to say hello world. Echo hello world, input that, and I say enter, and I should pop up hello world as well. Okay. So just make sure you can type that in and you get that. Okay, so we did a whole bunch of printing stuff in Python. What other stuff we did some basic math equations, right? So how do you do some arithmetic? Again, we're just getting used to this environment, playing around with it. You won't actually really do arithmetic really in a terminal. If you want to, you can, but it's unlikely. So to do basic arithmetic, I'm just going to do a sum. And to do that, I'm going to say also use echo. But in this case, I have to use a $sign, open up 2 double brackets, and can I have a sum like, you know, 5 plus 5 plus 5, for example. Enter, and you should get the answer 10. A lot of effort just to add 2 numbers together, but you know, there's a few other ways to do it. I think there's 2 other ways to add 2 numbers like this, but this is just one way. So just make sure that works. And again, we're just getting familiar with the environment and getting some, just getting familiar with it really. Okay, and again, we're going to do just one more little sum. We're going to create an equation that because that's what you also did in Python. So let's say we have create a variable. Let's say x equals 5, y equals 10. You'll see you might get bash terminals are very sensitive to spaces, right? If I say, for example, well, I'll show you how it works, the problems you get afterwards, but they can't have spaces between, these variable names. It'll give you problems, right? Then I'm going to create another variable called sum equals same $, brackets x plus y, and close brackets. So you should be following what I'm doing and getting the same outputs as well. Okay, again, we're just playing around with the bash terminal. Same stuff we did with Python, just to get familiar with it before we start using the more interesting things. Okay, then to output that sum, for example, we get echo, say the sum is $sum. So the dollar symbol allows you to access the variable that was stored. That's why we have the dollar symbol there. Into that, you should get the sum is 15. Okay, so try and get that. I'm gonna wait a bit of time for everybody to get to that stage at least. Uchenna, you don't need to delete. This is an interactive terminal, so you don't delete anything. Just press enter, go to the next line. So just go to the next line. Okay, so Letitia, you would get 5 because 5 plus 0 is 5. Does anybody agree with me? 5 plus 0 is 5. Or was that a trick question, Letitia? I don't know. Is it working for everyone? Thumbs up, so I know. Yes, Elwani, you are getting an error because you're missing something. Yeah, so the $sign allows you to access variables that we have created before. So this $sign allows you to access a variable. So if I don't have a $sign, if I type it out again, if I say echo, the sum is sum. If I just do it like that, then I'll just get sum, right? So the $sign allows you to access the variable name itself and the value. So Rahul, what is echo? Echo is just like print, like the print function in Python, and the $sign we use to access a variable. So we've created a variable y, and we created a variable x equal 5 and a variable sum. So we're just accessing it. The $sign allows it to access it. Okay, so there's a nice example. Somebody got a problem there. So let's say, let me just clear this. Sum equals, somebody gave a problem there. Sum equals $ x plus y. Can anybody see the problem with this command? What is the problem? The space. So as I said before, the space. Bash is very, very sensitive with spaces and syntax. Python doesn't care at all. You can have as many spaces, or probably it's not completely true, but it's more flexible. Yeah, is there a way to put notes in the terminal? Blessing, do you mean like comments? We will get to, you can put comments in the terminal. I think that's what you mean. Again, this is an interactive terminal. We don't want to put comments just yet. If you want to write a bash script, then you can do that too. Okay, so seems most people have gotten somewhere. So that's fine. So, okay, so now we've played around a little bit with the terminal. And yeah, so everybody seems to be on board. Okay, so now we're getting into more useful things. If you want to clear your terminal as well, say if I have a lot of this stuff and I want to clear it, just type in clear, and it starts like a fresh screen. Maybe I can make it even bigger. Okay, so now we get into more useful things that we want to head towards. So again, in the terminal, we need to know where we are actually in our computer, right? Obviously, we are expecting to be in this folder, but what is the absolute path, right? Because this is telling us the relative path. And if you remember in Python, when we were trying to read in CSV files in different locations, we spoke what absolute path, like the full path in your on your computer compared to the relative path, which is just relative to where you are. So to print the current working directory or the location, you just pwd. And you'll see it tells me currently that the terminal, the location where it's operating, or the directory is, this is the absolute path. C users, a username, and the folder name. Right, so you should have a different, when you type in pwd, you should have a different location, right? Because all our computers are different and where we store things. Rahul, so just to answer that, so your question about the double brackets, when you're learning a programming language like Python or any other one, there's what we call syntax, or the way you code, and that the programming language will understand it. So if we want to write arithmetic, do sums, we will need the double brackets and the $sign. So this is, you probably will never use it again. I'm just giving a simple example of just getting familiar with it. So don't worry about it. This is not really the purpose of learning bash terminals. But hopefully that answers your question. And why does it say no such file or directory? It's because you had a space somewhere. This is again going back to the syntax. So each programming language has its own style of writing, how you should write the commands. So bash is very sensitive to it. Okay, so we know where we are. So once we know where we are, we can kind of figure out where to go from there. Okay, so let's start exploring the directory and see what's inside it. Okay, so the first command, which you'll, so the commands from here onwards is what you'll use like 90% of the time, right? First, figure out where you are, and then check the contents of that directory. And what do you do for that? You type in ls or list, right? ls is pretty much one of the commands I use all the time. Normally, do you agree? Normally? How often do you use ls, list? Every day. and normally uses the terminal like every day. This is the day job, right? So ls we use all time, right? For just to get idea of, I'm in this directory. Okay, so let's see where I am. And does this compare to what my Windows Explorer says? Let's do a comparison. Maybe keep this on the side. Let's clear it again. Let's maybe show this on the side. Yeah, so the same files that I see here are obviously here as well. So they're all there. Ernest, the base, this actually refers to an Conda or Conda or specifically a Conda environment, but you don't need to worry about it. Just like when you drive a car, you don't necessarily have to know everything how the engine works to drive it. It's not really necessary for today's lesson. Okay, so ls will list all the can list all the contents of the folder or the directory you're currently in. Okay. What happens if you want to maybe get more details, maybe like the date that was created, or the size of the file as well? You can do that too. You're going to type ls space and then lh. I'll have to zoom that out a little bit. Let me do that again so I can see a bit clearer. LH, there we go. So this gives you a lot more details about the file itself. Obviously, all the file names are there. There's also a folder. You'll see the folder is in blue. Depending on your background, it might be a different color. And the date it was created or edited, the file size as well. This one is almost over a megabyte. The rest just refers to the file permissions, which I'm not going to touch on. This is just, if you want to get more details about the file itself, you can, just like you have in Windows Explorer, where you can see the date modified, the file size, and everything else, right? So a different, similar way and format. Okay. Marianne, so there must be a space between ls space lh. I don't see a space there, so you might not get the same output. Yes, you can. There's just like in Python, there's many ways to do things in Bash terminals. You can also do ll as well to get the similar results, but your file sizes are not human readable. So if you do ls space lh, you can list all your files, and it's you can see the file sizes are human readable. Yeah, Lubanzi, there's no dash. You need to have ls dash lh. That's the command you need. Okay. Clear this again. Okay, so that's that command. Okay. All right, but so we saw LSLH. So we can see that we have these files in a folder, but what happens if you want to see the contents of the folders as well, not just the files? We can do that too. We can say ls space dash lr. So this shows us the current files we have here, which we've seen before, but then also shows us, okay, so in this folder, chat files, we also have these files. So let me just expand this a little bit because it's probably unclear for you. Hello. So there were two students that gave me these two files that had very long names. So that we can see the contents of those files as well. So if you have many, you might have many folders as well, but many files, you can, quickly see that as well. Not sure if you can do that in Windows, that you see folders and split it up. Probably there might be a way, but I can't think of a way now to actually show the contents of folders as well. But there probably is a way. All right. So what happens if you're don't want to see the contents? You have a folder, but you maybe just want to see the contents of, sorry, in that directory, but you just want to see the contents of a specific folder. You can type ls and then the folder name, which is chat files, right? So in my case, I have a folder here. And how do I know it's a folder? Because it ends with a backslash. See, a backslash refers to a folder. Okay. So if I type ls chat files, you'll see that it just displays the contents, just the contents of that folder. Okay, let me clear that and do it again. So ls space chat files displays the contents of the folder. Fenyo, yes, it's definitely case sensitive, just like Python or any programming language. Commands are case sensitive, right? So if I do ls lr, it probably doesn't recognize the L command. I actually don't know what capital L could mean something else. So I don't know. So this definitely is case sensitive. And if it's a small L and a small R, see the small R Fenyo probably doesn't mean anything in Bash terminal. So it just gives you the file breakdown. Okay. So we were able to, we're in the current directory and we can kind of explore the contents of the files and see files inside it. But what happens if you want to see, a folder that is the parent folder or one folder up, right? So, so this symbol over here, right? In Windows, you can, if you want one folder, go one folder up, you can click this button to go one folder up. We also have a back button as well. But if you want to go one folder up in a Bash terminal, well, we're not moving there yet. Thank you for that feedback. But we just want to view we're just exploring the space around us, right? So to do that, we're going to keep on using ls. We just want to view the area around us, right? So let's just see what's one folder up. And to do that, we do ls space double dots. And you see there's a whole bunch of other stuff that you can see here. That's one folder up in my parent directory. Yours will be look different, and you can see I've got other folders there too. Other coding summer school folders that I've created, and some other stuff too. So that's if you type ls space dot, you'll see what's happening in your parent directory. Okay. Again, we're still currently in this folder. We're just exploring stuff outside. We haven't moved anywhere yet. Okay. And let's see if we can go even further back. Is there a parent directory to that directory? Can we go further back? Right. We can do that. Go ls dot backslash dot backslash. That'll take us even further back. So that takes me to even further back. So say, for example, I want to access any of these files, I can move around. I'm just showing you how to move around your drive to other folders and other locations. Okay, because we don't have a mouse, we don't have a visual explorer like in Windows. We have to kind of figure this out where we are. Okay, so we can go two folders back and we can see where it is. All right, so now we have a better idea, I guess, of how to move around to some degree. Let us say we want to see the contents of the previous folder or the previous day's folder that we did in Python. So let's just have a look at what that was called again. Says ls space dot, and we see, okay, so I want to look at this folder rather. I just want to see the contents of it, see if it's useful. Maybe there's data in it. Maybe there's a CSV file I want to use in. So let's see, how do I access it, right? So again, I'm just viewing it again. I just want to list the contents. So ls space dot backslash and the folder name. So folder name is CSS 2024. So I'm not going to type out the whole thing. One of the nice shortcuts or ways to program in Bash terminal is if you press tab, it will try to autocomplete for you. So if I press tab now, it will autocomplete until 2024_D, and then stops there because there are many other variants of D. It could be day 001, 02, 03, and whatnot. So I'll type out the rest. Day 02. That's the one. That's the folder I want. Okay, and I click on enter. And I can view or list the contents of that file. Right? I can view the contents of that file. And you can see the other folders in there too. Again, yours might look different. This is how I created my folder names. Yours might look different. So this is just an example of how you would access maybe a different folder in a different location, and just to really view the content. Okay, so I'm gonna just take a 5-minute break just to allow people to familiarize yourself and just play around with these commands. Yeah, so make sure you play around with these commands. Maybe there's other folders and files, just play around with it. So once you have, just give a thumbs up in the chat so I know to move on. But ls is what you'll use all the time. I only have 6 people that gave me thumbs up. 9 people. Okay, we're at about 50 people, which is fine. Almost 60. So again, if you feel that you're lost, like what am I doing? Why am I typing out these commands? Again, this is just an extra skill that is useful to learn about. Again, if you just want to focus on pandas and Python and reading Excel files, that's fine. Means you don't have to necessarily use this on a day-to-day basis. It's only for those that are really interested. Okay, so let's clear this and move on to the next section. Pamela can access an application.exe. Exe is for Windows, to run Windows applications only. So you can't run a Windows application in Linux. You can. There are programs that allow you to do it, but not necessarily. Okay, so now we're going to move on from the command we have, which is ls. So we've done ls. So I think this is a if you want to do a comment, it's hash, right? So we've done ls, which allows us to view contents, just to view contents of folders. So I've done ls, right? So if you want a comment, is just use a hash. So now we're going to move directories. We don't want to stay here in this folder. Let's move to another one. And we move with a command called cd, stands for change directory. Okay. So where do you want to move to? Or let's move to that other folder that I showed before. So the one that was this one up, I want to move to this folder here. To move to that folder there. So what do? I say CD. Let me just move this up a little bit. CD CSS 2024. What has to be? It's giving me error. I have to first move one up and then go into the folder. So CSS CD ... 2024 day 02. Okay. All right. So does everybody know why I actually first do ... and then the folder name? Can anybody tell me why I must first do ... and then the folder name? Why can't I just say the folder name? Why must I first say ... and then the folder name? Yeah, so we need to move we need to first move one folder up and then to access this folder, one directory up. Sorry. That's why we need to do that. There's a comment that Tabo says, as a beginner, I think Python has been easy to use in Git Bash. Yes, it definitely is. That's why we teach it first. And it's going to take a while to get used to these dollar signs. Yes, it will. So don't worry about it. This is an extra skill. You can just you can just you know, try and practice what we're doing, just so you have some exposure to it. But the dollar sign we hardly actually use. Again, the commands we're doing now is what we're going to focus on. Right, so we first need to go to that. So we're going to say ... and then the folder, and then the folder we want. Okay, so most important, do you see our prompt has changed? Our prompt isn't day 03 anymore. It's now day 02. All right, and now if we type ls, we can see now it shows the content of the current directory, which is different to before, right? We're showing what the current one is. Tabang, is it better to use CoCalc or the terminal Mac OS? Use terminal, far better. Use your own terminal. Mac OS has a built-in terminal. Please use that. CoCalc is only like a last resort. Use your own terminal rather than Mac OS. I explained how to get that in the notes. Okay, so we changed our directory, and now we can also list the contents and see where we are. And if we print the current working directory, you can see it's changed as well, right, to day 02. So this is how you start moving the directories. Again, why do we need to do this? Because we don't have a mouse. We need to write and give instructions to get everywhere in Bash, in a Bash terminal. All right, so again, common commands you'll use is ls, pwd, and cd, right? So this is all the notes, but you know, you will get used to that. All right, so let's see, we have a folder there, a bunch of folders and files. Okay, now how do you, so we can view stuff and we can move to other places. Now let's create our own folders, right? Let's create a folder. Create folders and files. So to create a folder, can I have a domain-specific folder name, please? Domain-specific folder name. Something interesting. Something interesting to make this more interesting. Domain-specific folder name. Anything you want. Fun GitHub. That's already domain specific unless you add data. That's really boring. COVID sewage virus levels. Okay, I like that. Okay. So to create a folder, you type the command make dir. This stands for make directory. And I'm going to use COVID underscore sewage underscore virus levels. Okay, so I created it. Let's see if it's in my current directory of ls, and there it is, right? There it is. It's in blue and it has a backslash, therefore it has been created. All right, so now let's move into that folder so we can maybe do stuff in there. How do we move into the folder or change directory? CD, I'm going to start typing COVID, so COV. I'm going to stop there because I can rely on bash to autocomplete. I'm going to type tab and it autocompletes the whole line for me. But it's a long name, I don't want to type it out. Very useful, you're going to use this quite a lot. So CD, I'm going to change directory, and now what does my prompt show me? Let me just do that again. Sorry, let me just clear that. Now a prompt shows me where I am, the directory I'm in. Okay, so let us we've created a folder, let's create a file, right? So can somebody give me a domain specific file name? Domain specific file name. Yeah, domain specific file name. With an extension as well. You don't actually have to. Oh goodness, who's doing that? Okay, here's Cape Town. Cape Town. Okay, well, how do you first create one? Okay, so how do you create a file? An empty file you use with touch. Cape Town CBD levels. I'm gonna rather use CSV rather than Excel file. Or actually text file. Let's just make our lives easy. You don't actually have to add a extension. I'm just making it a text file for now. Okay, so I've created that, and let's see what we have there. Okay, and there it is. Have another one there, so maybe let me create another one called touch virus.data. I've got two files, kept on CBD levels.txt and virus.data. I've got two files that I've created. So we've been doing this all now in a terminal, but has anything changed in Windows? Let's have a look. Go to our folder. And yes, I can see there is a folder called COVID sewage virus levels. And inside there are two files, the same ones that we've created, right? Same ones we've created. Okay, let's see what we have again. All right, so again, we creating files and folders. Now, how do we copy, rename, move, and delete files? Right, common tasks you can do in Windows. But again, assume you might have hundreds of thousands of files. This can easily be done in a bash terminal. All right, so let's work with, let's create another one, maybe call it touch notes.txt. So let's first copy a file. So say we want to copy the file notes, we can just use a command cp. The file we want to copy, and give me a name of the file we should copy it to. Well, another copy, but give me another name. any name you want. What should we call it? Okay, so we have notes v2.txt. Okay, let's have a look. Yeah, there it is. There is notes v2.txt, right? So we can copy files, right? You can also make copies, hundreds of copies of files as well, right? So I'm just showing you the bare minimum of what you can do in Bash. So the whole idea is, I mean, if you're just going to copy one file, delete one file, just do it in Windows. When you rename one file, I mean, just do it in Windows. But if there's hundreds of files, thousands of files, copy, rename, delete, I mean, Bash is a lot easier and more efficient in that way. And it's very few commands that you need to do to do that. So you can copy hundreds of files, rename, move, and delete at scale. That's the whole idea. All right, so let's we've copied a file. Now, how do we rename a file? Okay, so there's one command that has two functions. One is actually to rename and also move. They have a similar, the same command name, but to rename a file, let's rename virus data. So to rename, we use the mv command. I'm going to type virus data. And what should we rename virus.data to? Give me something applicable that can, what should you rename it to? What should we rename it to? Let's do C bacteria data. Okay. What is bacteria data? Okay, there we go. Bacteria.data. Okay, let me just clear my screen and do another list. All right, so virus data isn't there anymore. It's bacteria data. That's how you rename files. And again, you can rename to scale. You can rename hundreds of files in different formats, however you want it, but I'm just showing you the bare minimum. So that's how you can rename files, okay? How do you delete a file? You use the rm command, right? So which file should I delete? Give me a file I can delete here, sorry? Notes, okay, let's delete notes. So just type notes, .txt, and then it's removed, check ls again, and then it's removed. Again, so one example, one file, but remember, you can do this at scale. Hundreds of files, for example, okay. So those are files and that we can do, and we can do the same operations with folders. However, when we copy and remove, there's an extra parameter we need to add because a folder might have other files in it. So we're not just copying a folder itself, but the contents of that too. The same way, if we remove a folder, we can't just remove the folder, but the contents as well, right? So let's okay, we are here. So can somebody create another folder? How do you give me a name, a domain specific folder name I can create? Domain specific folder name. Detector noise curves. Okay. You want me to type a lot, so I'm going to just use a few letters here. Vector curves, whatever. And I see, okay, there is makedir, stands for make directory. So I've created it and there it is, it pops up. Okay, so how do I'll remove that? So, okay, well, let's first copy it, because they copy first. So to copy that, let's create, say, cp detect curves. What should we copy that folder as? Give me a name for the copy of that folder. Maybe curves 2, something like that. Curves 2. Okay, it says we need this parameter R because you're working with folders, right? Because there might be files in it. So when it is a copy, it doesn't just copy the folder itself, but the files inside it. So let me just access it again. And if I press the up arrow key, up or down, you'll see that it actually, if you keep on pressing up, you can see all the up and down, you can see all the previous commands we have written. So instead of typing stuff down, you can do the up and down arrow key and to access it. So I'm gonna just press up and find the previous command I had. I'm gonna put the R for recursive parameter. And if I do that, I don't get any errors. Type ls and I see that it has copied this folder accurately. So I mean, it is there. So clear an S. There is my 2 folder names. All right. And in the same way to remove, if I want to remove that folder, so I have to use, I can't just say remove that folder. For example, number 2, gonna give me an error. It's expecting a R. And there's deleted. Okay. Yeah, so we've covered quite a bit, so we're gonna take a break a bit early, but try and go through the notes, go through the examples that I've done, and just in your own folders and files, try and do the same thing. Create a temporary folder and file, move them around, delete them, and try and get that, and try and get it to work. So we'll take our break a bit early now, just to get a bit of practice, and we'll return at 11:15. Thank you. All right, so hopefully everyone is back and ready for some more of this bash stuff. Again, if you feel lost and what is the point of this? There's might be a point in the future, but just try to work with the code and understand, the lines of examples we're trying to do. Again, it's just a skill we're trying to bring across and show you the basics of terminals. So to see how everybody is understanding the content, because it seems this is too easy for everyone. I'm going to publish 2 short quizzes I would like everyone to do now. So Linux Quiz 1 and Linux Quiz 2, which is in Canvas. So shouldn't take you too long. To So there are 2 quizzes, Linux Quiz 1 and Linux Quiz 2. So please do that now. It's just really the basics of what you've done so far. Shouldn't take you too long to do. And hopefully you've done all the other quizzes before. All right, wait another few minutes for quiz 2 to be done. You people are still busy with that, so we'll wait another 2 minutes. Okay, so let us review the questions we had. Okay, which command is used to change the current working directory in the terminal? So what's the answer here? CD. How do you create a new directory called test in a terminal? Amira, I can't keep on answering. One answer is fine. It's okay. Somebody else, please. Well, I'll just copy what she said. Make directory. So make directory creates a directory or a folder for you called test. Which command is used to display the contents of a directory? ls, yeah. So ls or list. How do you move up one directory level in the terminal? How do you move up one? How do you move up one directory? So some people got confused between cd ... and ls ... So ls ... just views the contents in the one directory up. Cd ... you're actually moving to that directory, right? So the difference between the two. So cd ... is you're actually moving or changing directory one level up. How do you use the echo command to display the following? With answer for that one. So question 5's answer is echo hello world. Okay, let's see how I did. Yeah, I did pretty well. Okay, there were a few questions here which I wish you didn't cover. I was curious to see how much experience people had with Bash terminals. So if you got them wrong, it's okay. The ones that obviously the content we haven't covered yet. But question 1, what command is used to display the contents of a file? So we haven't covered that yet. We will do that shortly. But for those that do know, what is the answer here? Question 1. Display the contents of a file. How do you do that? What is the answer for that? Display the contents of a file to the terminal. So ls is to view files and folders, but cat, or I think short for concatenate, as far as I can remember, displays contents of a file. How do you create an empty file called file.txt? I think most people got this one correct. So to create an empty file, we use touch. How do you add text? So again, we haven't covered this yet. So, but for people that do know, what is the correct answer? Question 3, what is the correct answer? Echo, right? So we are redirecting this echo text to a file. So using echo. Actually, no, that won't work. I'm just curious to see what happens if you do this. You redirect that. I haven't tried that. Curious to see what happens. Okay, but the correct answer here would be echo. How do you move a file called file.txt from the current directory to a directory called folder? How do you move? Anything move is with mv, right? Move file.txt. Okay, how do you delete a file? Again, I think all these 3 questions people got correct. How do you remove a file? rm, file.txt. And how do you delete a directory? It's rm just with it, -r parameter. By folder, you need the -r for recursive. See how I did? 6 out of 6, I'm doing very well. I'm definitely gonna get a certificate. Cool. So How far are we with the content? So we've covered really the first section, logging into terminal, put a bit of variables and the echo command, ls or list. We've gone through that already. We've done creating folders and files. Yeah, we've done quite a bit, copying, renaming, moving, deleting. We've done that. Okay, so we're going to read on moving multiple files now. So how do you move multiple files? Okay. So let me clear my screen. So I want to go back. Let me just change something here. So let's get out of this folder and let's go back one up. We're going to go back to this folder over here. And get out of this one, this current one over there. So let's go back one directory up, and to do that, we're just go cd ... All right, so now we have moved one back one up. So let's list the contents again. And we can see we have a whole bunch of folders over here and other files with different file types. Okay, so let's say, for example, we have a lot more files, but let's say we want to move all our Python files to a separate folder completely, or data files to a separate folder just to kind of clean things up. So let's create a folder. Let's create a folder called Mac directory Py folders. List it. There it is. So let's say I want to move all my Python files, so all the files that end.py, to the Py folders, right? To clean up the folder, make it a bit more neat. So to do that, we'll use the move command. So now, if you do it in Windows Explorer, how would we do that? Right, we have to, maybe you'll select these files. Maybe you should see it that all my Python files. Those are my Python files. No, and move it and cut and paste it and move it right to this one. This is if you want to do it in Windows. Okay, but how do we do this in a terminal? And again, how do we do this if we have hundreds of thousands of files or a lot of files to work with, right? How do we do it? So let's say all the Python files, to move anything, we need the move command. And now we're going to learn about something called a wildcard, which is one of them is a star. And what that means is it looks for any, it's a search pattern that looks for anything. It'll move anything to a folder or somewhere else, right? But what we're specifying is star.py. We move that to the Py folder. So what that means is I'm moving, it'll look for anything, a search pattern that can have anything before .py, but it just must have .py at the end. So it can have anything at the beginning. It just must end with .py. Okay. So let's try that out. If I do that, there's a directory. I spelled it wrong, that's why. Folders. And let's list it. As you can see, all my Python files have been moved. They moved to somewhere. Or let's check if they are actually in Py folders. You can just do that with list, ls, Py folders, have a look. Yeah, all my Python files have now been moved with one single command. All right, and we can obviously play around with that if we want. For example, we want to move all the files. We can say move star dot star. Right, that'll move with any type of file that starts with something, ends with something with a certain extension. You can move it to another folder. All right, so this is an example of what the star character is what referred to as a wildcard. Right, it'll search for any pattern, any number of characters to move it. So very useful when you want to do like file management and whatnot. Okay. So I give an example of there's another wildcard, for example. The one is star and the other one is a question mark. So the one example I give there is if I have to move a file, see if I have a I have an example here. So let me see, maybe okay, let me create a file as I did here. So we're going to create a file called touch a1p.txt and another file called touch axp.txt. All right. And maybe create another one, touch a xyz p.txt. Why you create that, it's really up to you. So all those files should be the a1b, axb, axyb. You can have it however you want it. So now if I want to maybe move these files, so previously we had move star dot txt. Well, let's create just create a new folder called maybe text files, something like that. Okay, we have a new one called text files, and let's say we want to move them. So previously we learned about we can move star and .txt. That'll move all the files. It can have any file name. The ending extension can be just txt, and it will move it, right? But what happens if you want to kind of be more specific? It's not just any number of or a number of letters or anything like that. For example, we want to move only a single character, or the file name must have a single character that you want to search for. So for example, if I have a question mark b.txt to text files. Okay, let's see what happened. It moved a1b, it moved axb, but it didn't move xyzb. Okay, so let's just first check if it did move. Let's see, let's text files. They have been moved, right? So what does the star wild character do? It looks for a search pattern that only has a single letter, single character or letter. That's why it ignored that XYZ is multiple letters, so it just ignored it. All right, so if I wanted to move anything that starts with A and B, so maybe you have maybe like a lot of log files, for example, and a certain date range you're looking for. One of the exercises I have speaks about that. Then you can do that as well. So I was very specific with the what search pattern it should look for. If I didn't want to do that, if I wanted to, just send all the text files, then I can, just with a star character, right? So the notes describe using a wildcard, either staff or a question mark. All right, so let's start interacting with files now. We've been able to explore directories, move into directories, create files, and rename it. So now how do we actually interact with files themselves? All right, so let's see if we have what data files we have here. So we have, let's see the contents of data02, see what's in there. Okay, so we have a lot of CSV files. So how do we view the contents of those files? Well, these are, you can view flat files like CSV and text files and Python, coding files, for example, you can see quite easily. If you say not to view any of the contents of the file itself, you just say cat, the cat command, or I think it's concatenate, code for it. Cat, and then any file name, iris. Let's see. Why is it giving me an error? It's not working. Why is it giving me an error? Why can't I view it? Yeah, I'm in the wrong directory. Currently there's no iris. There's no iris file here. It's in the other directory. Right, it's in data02, right? So how do we have a choice, either move to this folder, or we can just use a relative path to view it, right? So I'm going to use a relative path because it's easier so I don't have to change the directory, just one command. So I'm going to say cat, the relative path, which is data02, and iris CSV. And there's the content of the file. Put it out. Okay. Alternatively, I could have gone to the folder itself and I just said, let me go cd data02. Let's clear this. And just said cat iris CSV. And there's a contents, right? So I could have done it either way. Both cases would have worked. So you can do it with any flat files like CSV, text files, or any recoding files. You can work with it. An Excel file probably won't work because it has formatting, so it won't process it correctly. Now let's say you have, this is quite a small file, it's only 150 lines. Let's say you have, if you have maybe like 1,000 rows or 10,000, 100,000 of rows, right? You don't want to use cat really. If you want to see the first 10 lines or the last 10 lines, you can use the head command. So if say head iris.csv shows you the first 10, or tail iris.csv shows you the last 10. So tail is sometimes quite useful. If you have a log file, log files obviously append data to the last row. So you can have a script, an automated script that continuously runs a tail command just to get the last line that was uploaded, for example. You can also specify how many lines of code you want. So by default, it's 10, but you can specify the number of lines as well. So you have tail and head you can use. So one of the other examples we had in the quiz, which we haven't covered yet, was we're starting to move to obviously viewing the content in the into the file, and also putting content in the file as well, right? So again, if you have a log file or data you want to actually put in a file, maybe notes or something, we can use echo again. So we can echo, maybe have the date here, 0201, and some value, maybe like, the temperature, probably about 30 degrees today. And we have this string, we have this information, and we want to store it somewhere in a file. You can quickly do this using double greater than symbol, and then specifying the file name, for example, like a log file, for example. So all that does is it takes the output of this echo, which will be the date and the temperature, and appends it or adds it to this file. And if the file isn't created, it'll create the file as well. So you won't see any output because the output is actually put into this file, right? Let's check if this file was created. We can say list it, and there we go. There's a log file is created over here. We can see it and see. Let's see the contents of the file. To see it, contents of any file, just say cat log file, and there's the contents, right? So again, also very handy feature that you might use to log information. If you have a simulation running, you can log the data as it's going into a separate file. All right. Now, there might be some cases where you might want to actually edit a file itself, the contents of a file. And then for that case, you need some kind of a text editor. Just like in Spyder, we had an editor where we can, create code and whatnot. So Bash also has its own type of editor. You get a few various types of editors you can use. The easier one we're going to show you today is Nano. There are other types like Vim, and I mean, there's quite a few you can use, but we're going to use Nano in this example. So if we want to create a file called, okay, give me a domain-specific file name to play around with. A domain-specific file name we can create and open up in the text editor. Domain-specific file name, please put it in the chat. How to thumbs up in Slack. Thank you, Eunice. I would use it, but it's quite a long file name. Okay, stock prices, stock prices. I don't like that dash there. But let's see what happens. So to create a file or to edit it, use a command nano and then the file name. If it doesn't exist, it'll create it. If it does exist, it'll just update it, right? So it's like a notepad text editor that you have. So if I do this, it'll open up this new little interface. It's a very basic text editor. Doesn't look very pretty, but it's very useful. Okay, so give me some content I can put in here. Stock prices, what content? Please put in the chat what content I can put in here. Okay, so VOD 28.45. What else? What is VOD? Value on day. What is? Oh, I'll put Vodacom. That's good. Because it actually sucks. 124. Tesla down 20%. Yeah, so it's a simple text editor. Nothing too special about it. You can add text, update it, delete things and remove it, right? So it's, if you're not used to Notepad, it's quite similar. There's a few features you have to get used to, but you know, you can update and create content. So how do you save it? So again, because Linux and Bash wants to be super special, there's a procedure to save things that you need to follow. So on Windows, these little, you'll see at the bottom, these are your control or features you need to access, right? So if I want to save a file, I have to press Control key. So let me actually share the screen here. Which is this probably the only thing you'll have to do. If you want to, you've written your content. So an example, I just said Linux was invented in 1991 by Linus Torvalds, and you've written the C programming language, right? So that's just, I wrote an example, but you can write whatever you want. Now to actually save the file, you have to hold Control and X. The bottom of the screen will change. And you just type in Y for yes, you want to save the changes. And you just press enter, right? Once you do that, you'll exit, and then you can go back to your terminal, right? So let's practice that. So I've written the content here, over here. So there it is. And I'm gonna say Control X. Because my background is quite light, you don't see the other options, but just press the letter Y and enter. That's pretty much it. So let's do that again. If I do Nano stock prices, let's maybe add another one. So the content is still there. I saved it. So I can add another stock, I don't know, stock, whatever I want to do. And I want to save it. I say Control and X, press the letter Y and enter, it saves. That's how you save a file in Nano. Okay. And if I want to view the contents, I can just say cat stock prices. And there's the contents of the file saved. So I'm gonna give you a bit of time just to practice that. It's about 5 minutes, just create a new file, whatever you want, add content and save it. So we just had load shedding, so give us a few minutes before we start again. Okay, cool. We're up and running again. Sorry for that brief break, but hopefully everybody is able to practice some more. So let's go through a few questions that you saw in the chat. How do we move the numbers to a different cell from the networks in the stock prices? I don't know what you mean by cell. It's not an Excel file or CSV file. This is a flat file. So we can't necessarily do that. We can't work with cells in here. This is a flat file, so we can't move it. Okay, can we merge two CSV files into one? Sure you can. What do you do if you want to edit the contents in the Nano file created? So we just again use Nano. So Nano stock prices. Just click on Nano stock prices. It'll open up the editor, and you can add whatever you want to. More stocks. And to save, Control X, press Y, enter, and that's how you save it. Nice complicated way that Nano has given you. That's why it's a lot more secure than Windows. Can you change file types maybe from CSV to text? Sure, you can change it if you want. So to change it, I would move stock prices. You're literally just renaming it actually. So stock prices to .txt. And then now stock prices is now txt. So you can rename it. Why does the echo to add text to file? Why do we use echo to add text to a file? We can just use Nano. Yes, you can just use Nano to do that. It's not a problem. So I was just giving an example of there might be cases if you want to automate certain log information. It's a quicker way to capture that information. So there are use cases where you would do that. But yes, you can just use Nano. It's not a problem. Yeah, so you don't want, we're not working with the cells here, or Excel spreadsheets or anything like that. This is flat files. You cannot create spaces. I saw the comment in there as well. You don't have to do that. That's not the purpose of this case. We're not doing like the kind of updates. Hadrian, yes, you can rename a GitHub repository, but just Google it. You can do that. Okay, let's move on. Gonna move a bit quicker because we lost time with load shedding, but it seems everybody finds this very easy, easier than Python. So I'm gonna try and move a bit quicker. Unless anybody thinks this is too fast. All right, so where were we? Moving around, creating files and folders. Interacting with files and saving files, okay. Find and search. Okay, so now we're in this section over here with find and search. So again, let's say you have thousands of files, you can search through it quite quickly in the terminal. So let's see how we can do that, right? So so let's first try and find file names. Right, let's first try and file names. Okay, so let's see where we are. Okay, we're currently here, so all the contents we can see. So let's maybe move one folder up to our the directory for that day. So let's go move one up. Okay. So let's say we want to find all the CSV files that started with person, right? All the CSV start with person, or even PER, or even P. I don't think there will be. Okay, there actually will be a few cases. So let's see. Start with that. Okay, so find name. Sorry. So input a command find we use for file names. Find name. And we're going to start with P, right? I'll start with P and then anything after that, right? So remember the star wildcard can refer to any search pattern, whereas the question mark is specific. Only one letter can be in that place, where star can be as many as you want. Okay, so let's find it, see what we get. So if I say enter, it'll look in the, it's looking in the current directory and all others in the current directory, and all folders in that is looking for any file that starts with P, right? So we can see, okay, in the folder data 02, there's patient, there's person, there's plot, there's pulsar, there's pi. So there's a whole bunch of options we can look for. Okay, so let's see if we want to look for maybe not just everything starts with P, but maybe just with person. So most cases it'll be something like person, and then anything after that, right? So we can find that for person, and we'll see, okay, there's a few CSV files that started with person and then ended with CSV. Remember, it didn't matter what type of file it was. An extension or a star wildcard can refer to any search pattern, any amount of characters or letters. So that is to find a file for file names. Okay, and how would the question mark character work? Well, again, that'll just be for a single case. So if you had, I don't really see an example. Okay, here we do have an example. Okay, so this one over here, maybe this would be a good example to use. Okay, so it's person split question mark .csv. So assuming I might have many more files or other categories, this could be maybe like a date, and we just want to only find a certain range of files. Let's see what we have. It'll find me all the files, but the search pattern can be a single character, right? The single space. So if you have maybe like multiple question marks, you can have, you know, maybe it might be a date, for example. You can maybe specify a month or date range with multiple question marks. If it was a star, for example, that could be really anything, multiple characters and then letters, maybe words even in between, right? So that's the difference between using the star and the question mark for finding. So that is for file names. Eunice, yes, you can use question mark and star in the same query. You'll have an exercise later on where we actually, you know, try and work that out. But yes, you can. Okay, so now once we have found that for files, how do we find file names? So instead of using find for file names, we use grep. So grep looks at the actual contents of the files. All right, so let's go back to our famous example that we had before. Our iris data set, where is the iris data set? It's in data 02. So again, we can use relative path or just go inside there and say data 02. And where's iris? Iris is there. We can just view the contents again, maybe not see everything and just see maybe the last 10 lines, tail, iris, and CSV. For the last 10 lines. And let's say we want to have, again, if thousands of files and we want to find a certain word, or we're looking for a certain search pattern, what we can do is we can use grep, the grep command with -n, which just gives us the line number in that file. And let's say we're looking for Virginica. Okay, that is the keyword that we're looking for. And in what type of file? Well, look through any CSV file if you find that. So star.csv. And what does it tell me? It tells me, well, it found in the iris file, line 102. It gives me the full line of where it found Virginica. Right, so this is how you can find certain text and files, or how you can find certain text in files, right? So assuming you have a lot of files or different search criteria and search dates, this is how you can work with it. Okay, there's a question, what is the difference between cat and tail? So I'm going to give an example. So this is cat iris with CSV. So I see all the contents of the file. Tail iris.csv shows me the last 10 lines of the file. Head iris.csv shows me the first 10 lines of the file. Pamela, is Git Bash case sensitive? Yes, it is. Case sensitive. I think we had that earlier this morning. Somebody asked that question. It is case sensitive. So you can't, if I do capital H. Okay, well, in that case, it doesn't give an error. But in most cases, you'll get an error. I think specifically for the parameters, like we had ls, if you have like capital L and small r, for example, this R was the specific capital R refers to recursion. So recursion in terms of looking through all the files of a folder. So in this case, it just ignored it because it's looking for capital R. But on the safe side, it is case sensitive, just like almost all programming languages. Okay, so just make sure you practice that and get the same, kind of queries that I'm getting. All right, so that actually covers pretty much all the content for learning really the basics of Bash terminals and how to access it. So again, just to recap a few things. I might just cover one more concept because there was a question about it. If you just look at the common commands that you'll almost use all the time, again, it's pwd. That'll print out the current working directory. It's ls to see for this all the content. It's cd, so where do you want to change your directory to? So you can change whatever directory to process the files differently. Then we work through make directory. So this will, I'm not going to create one, but you can mkdir create a directory or folder for you. Then we did copy. We did remove. We did move as well, and move allows you to rename a file and move a file as well. So that actually kind of gives you more information. The documentation isn't, or just gives you the basic other parameters that you can change. Or here they say arguments. We've seen a few before, so if you actually go to remove help, it actually explains some of the parameters. So we only use a few. Here's the one we've used before. So the capital R removes directories and the contents recursively. Yeah, so you can go through these, and obviously you can Google and find out other, if you have certain specific queries, you can go through that too. Okay, so I don't see any other questions. How do one copy the output into a text file? I'm not sure what you mean. How would one copy this output into a text file, e.g. the log file? So for example, do you mean ls? If you do ls, the contents of that, is that what you mean? Or let's see if something means something like that. Is that what you mean? Or when you're actually reading the contents of a file to copy it to a new file. So let's just see what's in this log file here. So cat log file 2. So any output to the screen, you can actually redirect to a file, right? So even this ls, as you saw, this ls, I just copied that output with the double greater than sign, these operators, to just copy that output to the file. And remember, this appends the contents to the file. If I want to create a new file each time, it's a single greater than sign. So that's redirect. So if I wanted to do something like, let's see, let's just first do another ls, and then ls log file 2. You'll see that cat log file 2, it does appended order. It is appended, the previous ls here. But now what happens if I want to create a new file each time when I do that redirect? Or for when I create a new file each time. So I can say ls single greater than operator, and then log file, and then cat log file. It'll rewrite the file, right? So that's the difference between a single greater than and a double greater than. The single greater than rewrites the file each time. Double greater than double greater than appends it. So there might be use cases where you want to do that. Okay, so why does the .sby project folder not show up? That is a great question. That is a great question. So to figure that out, we need some help from LS. See if this help actually works. Probably have a lot of options with LS. And there we go. So the parameter or the argument in this case that we want to look for is, we're going to use A. What does A stand for? Do not ignore entries starting with a dot, right? So we look at that folder that Eunice is speaking about. It is a hidden file. It starts with a dot. So how do we actually view it? Let's have a look. Let me clear this up. Clear the screen a little bit. So if I say ls, so currently there's nothing there. If I say ls-a, you'll see it shows up the .sby project. So there it is. It's hard to see all files that are hidden as well. So sometimes you might have hidden files, sometimes not. But you know, that is how to see the SPY project. Is there an undo command? Not really. Again, this is an interactive terminal. And you will probably see a limitation to all the things you've done, just like we did with Spider and the console. Once you make a command, that's it. Right. The next stage is writing a script. You have a certain set of instructions. You can save that as a bash script, and then you can run it. Right, because you're going to make a mistake and you have to keep on going back. That's the issue with, you know, running. If you want to, you know, reproduce some things, you have to write a bash script. Are there any other questions? Could I get a thumbs up? Okay, could I get a thumbs up if you want to see how to write bash scripts? Could I get a thumbs up if you want to see how to write a bash script? If you give me a thumbs up as a post, it messes up the chat channel. So just please reply. Please reply to my post. So I will ignore the. Please don't make a post. Don't post a thumbs up. Reply to my message. Okay. Louise, you don't want to see me write a bash script. Oh, there's two. Mariam as well. Melting face. What does a melting face mean? Mbali. Sarah, you don't want to see how to write bash scripts. Is it let me ask another question. Yes, so why did you take your thumbs down again? Oh, there we go. Louise and Bali. So you don't want to see it. Is it because it's not useful for you? Okay, you've done courses on writing scripts before, so this is pretty boring. Fair enough. Okay, we can maybe after lunch we can briefly cover bash scripts for those that are interested. Again, this can be a niche topic for you, Bash terminals and Linux. I mean, again, if Python was the only thing you came for, that's fine. And if you're just working with spreadsheets and whatnot, how to clean them up and whatnot, that's really just focus on that if that's what's important, and that's okay. Again, next week, our content is going to be more specifically focused on applications of Python, so machine learning, probability, and statistics. And then Thursday, Friday is more domain specific. You can check the timetable. But the common thread between all of them is you're going to be coding Python, and you can, if anything, just follow the code and try and copy what the lecturer or the trainer is trying to do. You'll at least learn something in terms of how they're coding, because each person you'll learn more from, right? So this shouldn't be the only Python course you do. You should carry on after this. I'll give more details about other Python courses you should be doing after this. Python shouldn't be the only programming language you learn as well. The more programming languages you learn, the more insight you have into, general concepts of programming. So it's important to have a broad understanding. So especially in the field of data science, if you should learn R as well, and SQL are good skills to learn too, besides Python. So yeah. What's the difference between Git and Ubuntu? So Andrew responded quite well there. So I think that question is probably related to why this terminal is called Git Bash. Why is it called Git Bash? And there was a reason behind that, because we're trying to cover two situations where we're trying to train you about having a version control or using GitHub as well as a terminal. So either late this afternoon or tomorrow, depending how far we get, we can show you a bit more about updating code to your GitHub repository the proper way. But it'll depend on how far we get. How do we save my history in Bash? Okay, so we haven't actually showed you yet how to do the history, unless you know about it. So just like if you press the up and down key, you can see all the commands you've done in this session, okay? If you type history, you can actually see all those commands as well. So all the commands we've done today have all been stored already. And if you want to save it, as Tessia has mentioned, we can again use that the redirect or the append feature. So we can say history. We can create a new file with this one and just say history backup. Create a backup, say, because there's a lot of rows, I won't do a cat. I'll rather do maybe like a tail history, just to see the last 10 lines. And then there's, you can see the last 10 lines that I did. So history, it's actually sometimes useful if when you're logging into servers and whatnot. I sometimes do that too. You forget the IP address, so then you can check your history, what the login details were. So, because you can't remember everything, and sometimes you forget to back up. So history is quite useful. Yeah, so thanks, Louise. So you can change you can change the number of lines as well. Instead of just 10, you can make it 100 or whatever you want. But yeah, I mean you can look at if you tail and then help. Again, you have various options to change the output, the number of lines that you have. Grant is a way when we view folder contents to display in a list format. So you mean like this, like a list format like that, Grant? Okay, well, we have done it before, so allel is one way, which is very much the same as this, I think, ls and ls space -l, and then allel is very much the same thing. But yeah, you can see it as a list format. Is there anything specific? Again, if you have an interest in this, obviously you might not have interest in it, but anything else you want to see after lunch? In terms of Bash related, we will cover a bit about writing a Bash script. But is there anything else you want to see? Maybe connecting to a server, copying files. Is there anything else you might want to see after lunch, or review some things you might have struggled with? Automation with Bash script. A for loop. Why wouldn't you do a for loop with Bash? You make your life difficult. Connect it to SQL, please. Goodness. It's all possible, but I need more than an afternoon to show you, because it's a lot of I need the database details for a SQL. Connecting to a server, I can show you how to connect to a dummy server if you want to. Okay, Krishna, you can use for loop to submit multiple jobs to HPC, for example. Yes, for that case, yeah, that would be a good example. Krishna, maybe you can show that you can show that if you want next week in your lecture, so you have a proper example. Yeah, deploying jobs are rather yeah, so Krishna, I'd rather let you do that because I'm sure you have a lot more examples than me to deploy jobs on a cluster. So I know Krishna is going to be giving a talk next week, Friday, on computational chemistry. So I can probably do a demo of that. I rather want to stick to simple stuff. Rather. So we'll speak a bit about Bash scripting after lunch. FTP from a site. Stephanie, if you can give me a site, maybe. I'll connect to a dummy server that you can at least read from. Normally, what is it? Pamela, what do you mean create an application? Okay, Adeshina, what does the RWE stand for? Those are different. It gives you the permissions specific to the file, user, group, and what is the other one normally? No, the permissions for file. You know, the read write, the read permissions. Oh, it's other, yeah, Krishna, yeah, it's other, yeah. So it's user group and other, yeah. So additionally, you don't have to worry about too much about it. It's just the permissions of the file itself, which you might need to change and whatnot. Read, write, execute, yeah. Maybe we look at awk and sed. Okay, we'll see. Deploy jobs, creating workflows. Yeah, I'll let Krishna focus on the HPC part. He has better examples for that and more experience with it. So you can wait for that. Yeah, I think if there's anything else, you can just put it in the you can put it in the chat. But we can have our lunch now, about 5 minutes early. And then we'll, if anybody has an AWS IP address I can log into, I can show you how to do that. Mine are all down at the moment, so I can't access it, but like a AWS server, Google Cloud server, I can demonstrate that. There's a dummy server I can access, but nothing I want to show that's public really. But yeah, okay, so we can have lunch now and we'll resume at 1:45, where Kim will be having her last talk on research software engineering. Cool, thank you very much.